Hello everyone, this is Sudhanshi from Gogaraj Rangaraju Institute of Engineering and Technology, third year IT department. I along with my teammates Sangameshwar and Ajit have successfully completed our mini project which is titled as Psychological Evaluation using Machine Learning. Coming to abstract, in recent years there has been a significant increase in mental health challenges. This project aims to address these challenges by integrating machine learning with psychological evaluation to improve mental health outcomes. The rising incidence of mental health issues becomes necessary for innovative approaches to healthcare. Traditional methods alone are insufficient to meet the growing demand for mental health services. Coming to existing system. This is the existing system for addressing mental health challenges. In the current landscape, addressing mental health challenges heavily relies on traditional methods of diagnosis and intervention. This means that our healthcare system is predominantly reactive. This reactive approach has several drawbacks. For one, it means that many individuals do not get the help they need until their situation has worsened considerably. Coming to proposed system. To overcome the drawbacks, we propose some of the methods and tools that are using innovative tools and technologies to provide more accurate and comprehensive assessments of an individual's mental health, and instead of waiting for symptoms to escalate, the proposed system emphasizes early intervention. Coming to activity diagram. This activity diagram explains about maps out the entire process from data collection to outcomes. This system starts with recognizing the increase in mental disorders by collecting data, developing model and trains the model and evaluates it. The ultimate goals of this system improves healthcare quality and enhances mental health. There are some of the other UML diagrams also, such as class diagram, sequence diagram, use case and deployment diagram. Coming to system architecture. The system architecture for predicting mental health issues helps us understand the flow of data and how different components interact. The process begins with collecting data from external sources and then loads, cleans, and pre-processes the data. To train the model, we use algorithms like logistic regression, random forest, and KNN. Once the model is trained, then we evaluate it with test data. The results of the evaluation are then visualized to better understand the model's performance. By following these steps, the system aims to provide a comprehensive approach to predicting mental health issues using machine learning. Firstly, we import libraries. In this section, we are importing the necessary libraries for our data analysis, and we are loading the dataset and perform initial data cleaning. Next, data visualization. In this, we are visualizing the data to gain insights into the relationships between different features related to mental health symptoms by selecting a subset of columns from the clean data frame. And these columns are stored in a new data frame data2. And in this, we create heat maps and displays them. We convert categorical data into numerical data for further analysis and modeling. The label encoder maps categorical values to numerical ones, making the data suitable for further analysis. Feature scaling is used to prepare data for machine learning algorithms. In this, first we initialize scalar which will standardize the features by removing the mean and scaling to unit variance. This process ensures that all features contribute equally to the model. And then splitting the data into training and testing data. Train test split. This function from scikit-learn splits the data into training and testing sets. Printing the shapes of the training and testing sets allows us to verify the split. Training the model involves how to define and train a logistic regression model. First, it creates logistic regression model with maximum of 1000 iterations, and then it trains models with X features and Y target variables. Accuracy for logistic regression. In this accuracy logistic is used to calculate the accuracy, and by print statement we print the accuracy of the model up to 4 decimals. Grid search for random forest classifier demonstrates how to use grid search to find the optimal hyperparameters for a random forest model. And then we find the accuracy for random forest also. Training KNN. This selection focuses on training a k nearest neighbors classifier. In this, first we define the train function, then initializes the KNN model and trains the KNN model by calling the function. Confusion matrix. In this, we visualize the performance of different classifiers using confusion matrices. We create a subplot with 3 columns for the confusion matrices then displays and sets the title for each subplot. Prediction function. This selection describes a function that makes predictions using the trained models based on user input. Creates user interface. This demonstrates how to create a user interface for predicting depression states based on different features. Output widget explains how to create an output widget to display the prediction result and handle button click event. Now, at the user interface, we are supposed to select our model among the three, that is, logistic regression, KNN, and random forest. As well as we have to give the rating values to the corresponding features mentioned over there. After filling the values, click on the predict button to get to know about your psychological or mental state. On comparing three algorithms, we obtained best accuracy by using KNN algorithm. Thank you.